But let's start. Once again, thank you for coming for the lecture Kubernetes Security Act Now before it's too late. What we will cover today, we will learn, we will remind maybe what is Kubernetes. We will see what is OWASP Kubernetes Top 10. We will understand how to protect Kubernetes control plane, how to protect workloads and nodes, and also we will discuss securing cloud provider integration, and we will see pros and cons of managed Kubernetes. Who from you, like day-to-day, manage Kubernetes cluster? Could you raise a hand? Okay, great. And who, like, also harden, who provide hardening for Kubernetes cluster? It's great. And I see some interaction. Maybe after this presentation, you will understand better how to like to protect Kubernetes. Couple of words about me. I have a lot of years in application security. As I said, I do like to work to OWASP conference a lot of years. And I also work a lot of years in Tufin. I'm responsible for application security at Tufin. You can contact me via LinkedIn, via Twitter. To read my blogs, I will add this presentation also to my blog. Also, a couple of personal words. I do like to travel, to read books, and to listen to music. And small, like, if you will know what is this place, then send me a message after the presentation. About Tufin, we are market leader in security policy automation. We are used by a lot of enterprise customers, and we are security policy company. And let's start. Maybe like for people who know, who use Kubernetes, it's like known facts that I will in next presentation, but I still need to put it to be on the same level. Okay, Kubernetes is open source platform. It's allowed us to manage containerized applications, and it's of name originated from Greek. It's a pilot, and the usual abbreviation KAS, and I will use it in like in many places in my presentation. Therefore, I need to tell you what is K8S. It's K, 8 letters, and S, and it's a project that was open sourced by Google in 2014. Why Kubernetes? Maybe for many like known fact, but de facto it's standard for container orchestration. It allows us to solve a lot of problems with containerized applications. Automation, operation tasks, okay? Deployment, patches, or recovery from fails. Everything Kubernetes will allow to sell you. Why Kubernetes security is critical? I will start from two examples that published in internet. First example provided by Aqua Security, one YAML from away from disaster, one misconfiguration in YAML file, an attacker like expose all sensitive data in your cluster. Okay. The second one provided by small company Wiz, and it's called Ingress Nightmare. And what is the vulnerability? It's because vulnerability in Ingress controller, essential component in Kubernetes, full takeover of a cluster. Okay, and of course you can find additional examples in internet. Okay, so impact of such Kubernetes incident, it's security incident even higher. Okay, unauthorized access to your cluster, data breaches, service disruption, denial of service, and malicious code execution within your cluster. Maybe you know a lot of examples. Oh, an attacker was able to take over some cluster and to like mine Bitcoin. Okay, in your cluster, it's when someone will receive a bill, it will understand it, but we can prevent it. We will learn how to prevent it. Now we understand why security is important. We did understand risk and impact. Now we will learn how to protect Kubernetes secure way. We will start with using OWASP Kubernetes Top 10 is our guide, and the list is long. Okay, It's a lot of issues, top 10 list, and it's protected by open worldwide application security project, 10 most critical security risks, and should be key resource for anyone who will work with Kubernetes security. This is architecture, and we need to like follow the architecture of any product, in this case, Kubernetes. It's contain control plane and nodes. And you see, architecture is not simple, a long list. I will happy you will focus, and I am also happy that this presentation before the lunch, after lunch, this presentation more difficult. Okay, let's start from control plane. KubeAPI server, I need to remind to everyone what it is. So who knows, okay, it's known fact, but we need to remind to everyone. It's exposed Kubernetes API. etcd is key value store for all cluster data. Kube scheduler, it's just assign pods to nodes, and Kube control manager, run controller to implement cluster level functions. Let's protect components one by one. We need to start to protect KubeAPI server. Risk if KubeAPI server component is unauthenticated, then anyone can gain control over your cluster. Attacker can execute administrative command. It's like very big risk. Sensitive data, like secret, can be exposed. And of course, full cluster compromise. It's key aspect of risk key 06 broken authentication. Let's see how we will mitigate it. We need to configure authentication to Kubernetes API. And first of all, don't use your own authentication. Use standard authentication. Okay. For example, for human user, configure OpenID Connect authentication. Enforce two-factor or multi-factor authentication for human users. Okay. In the next, short-lived secure service account tokens. And avoid an opposite, avoid long-lived credentials where it's possible. And it's not recommended to use certificate for human and user authentication. It's difficult to revoke. Next component, etcd. As we discussed, it's including sensitive secret. And I will tell you a little secret. The information that you put on secrets, by default, it's not encrypted. It's just base 64 encoded. From the security point of view, it's plain text. So once again, default, you use Kubernetes, by default, secrets, plain text, wow. So you need to encrypt it. So attacker can take control over your cluster, of course, like modification of your data, denial of service. All this is discussed in key 09, misconfiguration cluster components, and key 08, secret management. Let's discuss how we will resolve it. We will need to start from establishing secure connection to etcd. Configure TLS communication for etcd. Protect access to etcd with firewalls, that only connection from authorized components, and configure client certificate authentication for all peer communication, for all client communications. Encrypt data at rest for etcd. How can you do it? Use built-in encryption provider. Recommended provider ASGCM. Okay, it's most secure provider, and you can use it, and your information will be encrypted. Of course, you need to rotate your key in a regular way. Next, two components, Kube scheduler and Kube controller manager. It's we will not discuss it now, but you need to remind that we will need to protect it using RBAC. Okay, when we will discuss RBAC over like 0.3 overlay permissive RBAC, you need to remember when we will configure RBAC, RBAC will protect these important components. Okay, we have configured control plane, our brain. Now let's protect our nodes where application runs. What we need to do, we need to disallow privileged containers. We need to prevent from a process to gain more privileges than its parent. It's recommended to prevent application from running as root, and to ensure to implement read-only file system. It's related to K01 excessive permissions. And let's see one by one risk by one. The first risk is privileged containers. So what's privileged containers? Privileged containers is the same root privileges as the host machine, okay? Why it's a bad idea? You know, an attacker compromise a container, he will exactly start to run, gain control over the host, okay? How we will mitigate it? Just set privilege false in your security context. The next one. If a process will gain more privilege than its parent, then if a compromised container just can escalate privilege to gain root access to your node. Mitigate it. Set a low privilege escalation false in your security context. Let's prevent from application to run as a root. Because immediately, if the attacker will gain access, he will take root privilege of the container. So mitigation, two properties in security context: run as non-root and run as user to specific non-zero UID. The last issue risk we discussed in nodes, root file system, and the mitigation, read-only file system true in your security context. I also want to introduce you a relatively new feature, pod security admission, PSA. It was introduced in 1.24 and above. It enforced pod security policies and replaced deprecated pod security policy, PSP, and it's recommended to use restricted profile. And this profile will ensure that your containers pod configure security setting as we discussed above. In addition, additional hardening, for example, dropping of all Linux capabilities, and use it. It's great. Let's discuss RBAC. Do you remember I've promised that we will discuss RBAC? Now it's time. What is the problem of overlay permissive RBAC? If we have too many permissions to users or to service account, and a risk obvious, escalate privilege to gain more control and potential take your cluster. This attack usually like target high privilege account like cluster admin and accounts we have discussed before, kube scheduler, kube controller manager. Now, if you will configure cluster, you will be able to protect this important component. How we mitigate this component? Grant only essential permissions, use granular verb and resources, and restrict permission to specific namespace. And please don't use cluster admin for daily operation. Use it only for essentials operations. Additional interesting fact. Do you know when you deploy Kubernetes, by default, it allows communication from any pod to any other pod? Okay, what's the risk? If an attacker will compromise any pod, he will be able to access all pods in your cluster. Okay, so attacker will be able to access other containers or private APIs, and it's key aspect of network segmentation. If you will configure network policy and you will ensure that only need communication allowed in your cluster, then you will mitigate this risk. Also, apply policies per namespace. For example, isolate test environment from production environment via these policies. So this will mitigate your risk. Let's discuss two important components that we have in nodes. Kubelet API. What risk if we have unsecured Kubelet API? First of all, Kubelet is agents that we have in each node. It's control pod lifecycle and allow like node label resource manager. If an attacker will access Kubelet API, he will also can control your node and full cluster like takeover of your cluster. Once again, we discussed it in key 09. Key 09, it's important. We need to configure You see, you need misconfiguration. It's very important problem. You need to configure a cluster in proper way. How we'll protect our Kubernetes API? Disable anonymous access, configure authentication, delegate authorization to API server, and configure RBAC. Kubeproxy, it's network proxy on each nodes. How we'll protect it? RBAC and network policies, okay? And that it is protected. Okay, we have configured everything. Do you think it is enough? No. Audit logs. If you don't have enough audit logs, then you will not able to understand early that you have security incident. And an attacker can like work a lot of time, and attackers will be undetected. How you will resolve it, we'll see on the next slide, but it's key aspect of key 05. So let's discuss how it's like simple. You need to enable logs in each component: API server, kubelet logs, container logs, network policy logs. Okay. Also, aggregate logs in some secure logging solution. You need to ensure that this solution will protect your logs from tampering. Store logs for defined period of time, like half years. It's recommended half years, because like if you will not store it, you will not be able to research your incident. Okay, now we have configured our cluster. We have achieved our hardening. We have configured logs. Is it all? No, we need to ensure that what run on cluster. We need to ensure that we need to disallow images from untrusted registers. It's key 04. And supply chain vulnerability, it's K02 and K10 vulnerable components. Let's see one by one. Disallow. Use only internal or trusted registers. Okay. Use admission control policy that allow only these registers. Supply chain vulnerabilities. You need to validate image integrity through each build phase. It is important. It's recommended to configure admission control policies that will prevent unapproved images. Images that not signed, not scanned for vulnerabilities, don't have approved SBOM, should not be allowed. K10. We need to scan for vulnerabilities on like periodic way. Do you remember the second example of this? You will be able to understand it on time, and then you apply a patch and you are not vulnerable to such vulnerabilities. Now I want to discuss cloud, because in most cases, Kubernetes application will be deployed in production in cloud. So we need to understand what risk related to this. And we have two components. We need to understand what is Cloud Controller Manager, cloud provider APIs, and how we'll mitigate risk related to this component. So Cloud Controller Manager, CCM, just components that embed cloud-specific logic into Kubernetes. It allows to Kubernetes to connect to cloud providers. What risk? Infrastructure manipulation. If an attacker will be able to compromise CCM, he will be able to manipulate your cloud infrastructure to like allocate additional VMs, etc., and you will see huge bill in the end. CCM store cloud API credentials, credentials that you access to cloud, should be secured. If you will not store it in secure way, an attacker will be able to access these credentials and once again access to your cloud environment. It will be pivot entry point and will control like your entire cloud infrastructure. How we mitigate it? Least privilege IAM roles. Okay. Secure credential. You need to store your credentials in secure way. Audit logging is like not related only to cloud, but in cloud it's very important. You need to configure audit logging, and important to monitor your logging periodically to understand if you have any suspicious activities. Also, recommended to restrict network access, ensure that CCM can access only to like required cloud APIs. Let's discuss cloud provider APIs. This APIs that exposed by service provider like AWS, Azure, Google Cloud, and other. And via this API, via CCM, Kubernetes manage infrastructure of cloud. What risk? Possible risk of weak or missing authentication. Anyone can access and interact with your cloud resources. Okay. If you will provide to these credentials excessive permissions, an attacker who will able to breach, you will take full control of your cloud infrastructure. And once again, without logging, you will not able to understand what's the problem, what a security incidents. Mitigation, authentication, list privilege, audit logging, and monitor for anomalies. Before we will finish, I want to discuss managing Kubernetes. It can simplify your access, okay? Major cloud providers do provide managed Kubernetes. It's GK for cloud, EKS for Amazon, or AKS for Azure. And of course, a lot of benefits to use it. Like it's from security point of view, it's implement Kubernetes security best practices. It's manage upgrades and patches. I will use the same example of this. Like every provider will provide a fix. You just need to do nothing, okay? And of course, it's seamless integration with other cloud services, and you can find a lot of additional benefits. But of course, some disadvantages. First of all, cost. Usually, it costs more than self-managed cluster, and less control or communication and customization. Take it or leave it. Okay, you just need to use what is you have in this provider. And complexity. I will very important from a security point of view. You need to understand each checkbox in your provider because it does not provide anything. You need to ensure that your provider like harden everything that we have discussed before. If anything is missed, you need to configure it by yourself. Otherwise, your managed cluster will be at risk. One additional cause that I want to discuss, the disadvantage, you will depend on provider updates. It means you will need to wait till provider will fix this vulnerability in this controller we have discussed above, and only then you will be able to take it in your cloud. Dear all, we have finished our presentation, and you know what the security of Kubernetes is important, and more than you know how to achieve this Kubernetes security clustering. And I want to thank you. You can contact me and to read my blog. Thank you very much.